Good morning, guys. So, today I'm taking notes with you on compound interest, and there are two formulas for compound interest that I want you to write down. These two formulas are very important. We're going to talk about the difference between the two. But the first formula is for this this formula, continuous interest, is for problem number one. Number one says, Frank invests $23,000 to an account in 1990. The account earns 2.8% interest compounded continuously. In what year will the account reach $100,000? So in this problem, A is the result, the future value of the account. P is the initial value that I invested, the principal, and R is the interest rate, T is time, okay? So in this problem, it is asking us to solve for time, okay? Let's plug everything into that formula. 100,000 is what we want it to reach. Initially, he invested $23,000. E is our, just part of the formula. Again, it's a number. And R, this as a decimal is 0.028. So 0.028 times time. So that equation is after we plug everything in. We're going to solve for t just like we have been doing for exponential equations. We got to divide by this number in front of e before I can change it to a logarithm. So 100,000 divided by 23,000 is 4.3. Let's just go with 4.35. 4.35, and that equals e to the point, I didn't write that correctly up here. There's a 0 in front of that, but let's write that right. Alright, 0.28 times t. So now we're going to change it to a natural logarithm. I'm sorry, we don't need that e there. Okay, so ln of 4.35 is ln of 4.35 is 1.47. 1.47, and now I'm finally going to get my final answer, by dividing by 0.028. And t equals I wrote that wrong. There we go. Okay. 52 and a half years. That is a long time. I would say that that's not a very good interest rate for a retirement account. So I would assume that Frank does not want to retire after 52 years of working. He'd be a old man. Okay, in number two. This one is going to use the other formula. All right, let's talk about why. It does not use the phrase compounded continuously. So by not using that phrase, it is going to use the other formula. That formula is obviously more complicated. I'm going to rewrite it down here so I don't have to keep going back and forth. I've got A equals P. So we have a value n in this formula that's not in the other one. And n is the number of times it's compounded in a year. Okay, so compounded weekly would be 52 times a year. Compounded semi-annually would be twice a year. And that's what this one says. Compounded daily would be 365 times a year. So again, guys, it is, if it says compounded an amount of time, like this one says compounded semi-annually, that's how I know to use this formula. A person invests $4,500 in a bank. The bank pays 6.25% interest compounded semi-annually. The interest, or to the nearest tenth of a year, how long will the person leave the money in the bank until it reaches $13,300? Okay, so I'm going to put all of that in my equation. I've got, this is the principal investment, this is the amount resulting, this is my rate, and I know semi-annually means twice a year, okay? And we are solving for t again, okay? So the first thing I'm going to do in that problem is simplify the inside. 1, the inside of those parentheses. 1 plus 0.0625 divided by 2. So I'm not going to round that. Be careful, this is an interest rate and it's really important. Any decimal there could result in hundreds of dollars. So let's don't round that. 1.03125. 1.03125. And that is still to the power of 2t. And I said I was running out of room here. I am going to divide by 4,500. Okay, and then I'm going to get my next step. Okay. Good. Okay. 2.95. We'll go with 2.956 or 96. 2.96. Okay. In my next step, I am solving. Let's zoom in so I can write that. 1.03125 to the 2t. This is going in a logarithm. It's going to be a really little. I'm writing it really little. Okay. All right. So now we have log base 1033. Right? Did I say that correctly? Okay. And then 2.96. 35.3. We'll round, because it said round to the nearest tenth of a year. 30, what was it? 35.3. 35.3 years. Okay? Alright, guys. The next part is about half-life. It's about chemistry. Now, I know that chemistry is a great place to apply exponential equations because of this half-life situation. Some of you have already taken chemistry, so you probably have studied this a little bit already. Half-life means that inside my parentheses, if I was going to use this formula like for growth and decay, B is 0.5. Okay? Let's read the problem. Element X decays radioactively with a half-life of 9 minutes. If there are 170 grams of element X, how long to the 10th of a minute would it take for the element to reach 26 grams? So I want it to decay. It started out at 170, and I want it to decay to 26 grams. And I want to see how long that's going to take. So this is not a compound interest problem. It's a little different. It's about half-life, okay? Half-life means however long that element takes to decrease by half. It takes 9 minutes for this element too. So let's solve this problem. 26 divided by 170. 0.15. 0.153. And now we're going to take it into a logarithm. Log base 0.5. So all these logarithms will have a base of 0.5 or a half for half-life. .7. Now, that's not actually the final answer. It doesn't mean it takes 2.7 minutes. It actually means it takes 2.7 revolutions of 9 minutes. So I just want to multiply by 9. 2.7 times 9 is my final answer, okay? Which would be 24.3 minutes. And remember, that was probably going to be on, 2.7 would be on a multiple choice question as an answer choice, so be careful. Make sure you go back and multiply by the half-life. Good job, guys. I want you to try number 4 and 5 on your own, and then watch the second video when I go over them. Thanks, guys.